Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video I will talk to you about hypothesis tests comparing two populations, and in particular I will talk to you about t-tests with paired data. So this video assumes that you've read the chapter, which is 10.3 in this case. You feel comfortable with notation and definitions, and in general with basic ideas of hypothesis testing. Okay, so what we're going to do, we're going to solve a couple of problems from Module 3, Section 10.3. And let's go ahead and take a look at problem 1. Okay, so we have the following information given to us, and they want us to answer all of these questions. Let's go ahead and take a look at the data. This data doesn't really have any context, right? So we just have sample 1 and sample 2, and we have a situation where we have paired data. Okay, so for pair 1, the first value is 9 and the second one is 2, and you can just kind of go through all of them. And the main idea here is that these numbers come in pairs. They cannot be separated. This is an example of a dependent example of sets. Okay, so what we're going to do is the following. We're going to click over here and open your data in Excel so you don't have to retype it. Open up. Okay, I'm going to highlight my values and copy them, and then paste in this file that you can download on Blackboard. Okay, let's delete everything that's already here. Let's do it again. Here we go. Okay, so we have our data copied into our working file. What I'm going to do, I'm going to find the difference between these two sets of data. So let's take a look at what the problem is asking us to do. Okay, let's see. We want to state the null alternative hypothesis to test if the population represented by sample 1 has a mean that is 2 units higher than the population represented by sample 2. Okay, so if sample 1 is higher than sample 2, how are we going to find our difference? We're going to say sample 1 minus sample 2, and I'm going to drag all of these cells down here. Okay, so you can take a look at this data and make sense out of it. Okay, so this observation is 7 units higher than observation in sample 2 for the same pair, right? So this is presumably coming from the same individual or subject. There's no difference here, so that's 0. This one is lower than the second one, so -3, and so forth. Okay? Now, on this side over here, I've already computed the difference, the mean of the difference and the standard deviation. But let me just go ahead and delete it to remind you how to do it. You would say average of what? We want to find the average of these cells right here. Standard deviation, this is a sample, so stdev.s, highlight these cells right here. Okay, that's done, and we want to see what if on average these values are higher than the ones in sample 2 by 2, right? So that's what the problem is asking us. Let me get rid of this. So okay, by 2 units or higher. Okay, so that means what? Let me just go ahead and write what's going on here. I'm going to put 2 over here, and for my alternative hypothesis, 2 over here. Okay, so now that I have all my values computed, let's answer all the questions. Okay, first choose the correct answer. Okay, we're going to select which one? F. Okay, the null hypothesis would say that the difference on average is less than 2 units, less than or equal to, and the alternative hypothesis will say that it's greater than 2. Okay, calculate the appropriate test statistics, we need to make sure we use correct alpha level, so that's 0.05. Okay, 0.05, that's already here. The null hypothesis value is 2. Sample mean, I'm just going to say that's 3.5, right? So I'm copying my sample mean from here. Let me highlight it in a different color. Okay, sample standard deviation, and I'm going to round, let's say, to 3 decimal places, 276, and I have a sample size 8. Now I got my values. Okay, so what is the first problem asking us to do? The test statistic 0.99. They want 2 decimal places. Okay, good so far. Critical values, I double check and see, okay, my test is right tail. Okay, so my critical value will be 1.89. 1.89. Looking good so far. Interpret the result. Okay, this value right here is less than that one. It does not fall into the critical region, right? So the test statistic is less than the critical value. We do not reject the null hypothesis. There is insufficient evidence that the mean sample 1 is 2 units higher than the mean of sample 2. Looking good. Okay, we're gonna do the same problem with the p-value method. We go back to our file, and this is a one-tail test. It's a right tail test, so the p-value 0.18. 3, okay, and there were 3 decimal places, so that would be 0.177. Conclusion should still be the same. The p-value is greater than the significance level, a lot bigger than 0.05. We do not reject the null hypothesis. There is insufficient evidence, same as above. Okay, so these two should actually match. You should get the same answer. Okay, one last thing. Okay, what assumptions should we make, or should we make in order to perform this procedure? Okay, well, the samples are dependent, so it's either C or D, and the difference must follow which distribution? Not uniform, normal, right? Normal distribution. So that would be part D here. Okay, so that is your first problem. That's just checking the mechanics of doing a hypothesis testing for paired set of data. Okay, so let's go ahead and do a problem that is more of an application problem. Okay, let's take a look at this one. Let's see what we have here. A new weight loss program claims that participants will lose an average of more than 10 pounds after completing it. Okay? Then accompanying data table shows the weights of 8 individuals before and after the program. So let's go ahead and see that data. Just like before, we're going to open it in Excel. I'm going to copy these cells and put them in my file. Okay, let's see. The difference is from sample 1 minus sample 2. I'm going to double check if that's what actually they want me to do. Okay, let mu D be the population mean of matched pair difference for the weight before the program minus the weight after the program. So that is correct. I want to emphasize that sometimes you will have to compute this difference the other way around. So it would be sample 2 minus sample 1. So definitely pay careful attention to what the problem is asking. And if you set it up, just take a look at your difference, okay? We're going to see if the difference on average is greater than 10, right? It's greater than 10. So if you take a look at these numbers, this should make sense. This should actually support your statement right here somewhat. Okay, if you get all the negative numbers, then it's not supporting your alternative hypothesis at all. But here I have positive 23, positive 19, 12, 16, and so forth. So I have some ground for this hypothesis testing. Okay, let's see. Let me redo this just in case, because if we have a different sample size, then I will just redo it, right? In this case, it's going to be the same thing. Nope, standard deviation of a sample. I'm going to get these values right here. Okay, so let's go back to the problem and see what they want us to do. Perform a hypothesis test using alpha 0.05 to determine if the average weight loss was more than 10 pounds for participants in the weight loss program. Okay, more than 10, I'm looking, and it's option C. Okay, let's check. This is looking good so far. Calculate the appropriate statistics. Okay, let's go back to our file. So what is our alpha level? 0.05, so that's good. The null hypothesis is 10. Sample mean is 13.875. Standard deviation 7.453. 8 is still the sample size. Okay, so that's good. So our test statistic is 1.47. Looking great. Critical value, again, this is a right tail test. 1.89. That didn't change. Okay. Since the test statistic, this value right here, is less than 1.89, we do not reject hypothesis again. There is insufficient evidence to claim that the mean score is lower after the weight loss program by 10 units, by 10 pounds, right? Okay. What about p-value? It should be bigger than alpha level, right? Let's see. Is it? Yes. 0.092. 0.092. Okay. Since the p-value is greater than the significance level, we do not reject the null hypothesis. There is insufficient evidence that the mean score is lower after the weight loss program. Let's check this. This is looking good. Okay. Construct a 90% confidence interval to estimate the average weight loss for individuals in the program and interpret the result. Okay, so 90% confidence interval. So here you would do what? You would do the t interval. You would do the t interval with this mean, this standard deviation in the sample size, right? So you can go back to one of your files that you have for chapter 9 and use that setup to find the upper confidence level limit and the lower. Okay, now I don't have the file open, but you guys can do it on your own. So let me just remind you a couple of things. The first thing that we're going to do when we solve problems from this section is decide if we have independent samples. If you have independent samples, you will be using what we call two-sample t-test. Okay, the mechanics are different, and you might notice that the sample sizes in here are different too. Okay, that's one indicator that this is two samples that are independent. Okay, now they don't have to be different. They can be the same, but they're just not paired. All right. So if you have two samples that are independent and population variances are unknown and not equal, you will be using two-sample t-test. If you have paired data, you will really be doing t-test, which we have already done before in previous chapter. But now we're using the difference. So we're using hypothesis testing, t-test on the difference. And how you're going to set it up meaning is it sample 1 minus sample 2? That depends on the problem. So just be very careful when you read each of the problems. All right, thank you for watching, and I hope this helps with your homework.